Oops. All right, maybe this is now working, I think, and perhaps someone in Slack could confirm that. It appears to be working, at least for me. Just going to pop out the chat real quick in case anybody says anything there. And yeah, so here we are. And I guess I'm not sure whether anyone is paying attention to this at the moment, so maybe I'll hold off at Liz. Okay, there we go. It's working. All right, good confirmation. So yeah, I guess the plan for this week is maybe to talk a little bit about Pandas and Numpy. We did some stuff with Numpy last week about using masks and things like that with Numpy. But we haven't really dealt with files, and I think my understanding is that many people who are still participating in the course are on to like exercises 5, maybe exercise 6, and at that stage it starts to be useful to make sure that we go back and just make sure the stuff about Pandas and Numpy are kind of clear. I didn't see any questions in Slack in advance. I didn't see any questions in the live stream chat. So with that being the case, I think what I'll try to do is maybe go over a couple things that I think are useful, and then perhaps if there are any questions, you can ask those as well. The thought for me for where to get started is, I guess you can see here that I have this Jupyter notebook where I've just put in this kind of Pandas and Numpy question and answer heading. And what I'm going to do is, I think, just to kind of compare how Pandas and Numpy relate to one another, and to maybe show you a few small differences, I thought we could start by loading in the data file that's used in lesson 5, just to have something to kind of play around with. It's a fairly straightforward data file, and so that kind of makes a nice place to toy around, and just to show, yeah, a few of the kind of differences in terms of how I work with Numpy and with Pandas, for example. I'm not really a Pandas person so much. I mean, I think I have an appreciation for Pandas, but don't use it that often. So I'm definitely more familiar with Numpy, and that will probably become clear as some of these things go on. But all I've done here, if you can see what's in the few cells that I've run so far, is I just printed out the working directory, so that showed me where I am. I'm working on my own computer, so if you do this same command on Binder, for instance, you'll get something different. And then I went into the notebooks/L5 directory using this command cd to change directories. So now the directory I'm working in is here. So in that directory, if I run this command ls to list the files and directories that are there, I see this stuff, which is basically all of the files that are used in lesson 5. The important one here is this Kumpula June 2016 with metadata file. So we can add a cell here just for getting started. And of course, the first thing we're going to do with both Pandas and Numpy is to import the two. Import Pandas as PD and import Numpy as NP. These are the kind of common shorthand abbreviations for both of those libraries, and we'll make them both available to us, and then we can kind of start working with that stuff. So we'll just import both of those quickly. My understanding is that there were some issues with Binder maybe the last week or so. I mentioned in Slack, at least to the instructors for the course, that I haven't been been able to reproduce any problems with binders, so I'm kind of not totally clear what the issue could be. But again, if someone has been having problems and could maybe give a little bit more information in Slack, I can also comment on that. For the moment, though, at least in principle on Binder, you should be able to import both Pandas and Numpy the same way I have. And the first thing we're going to do is to read in the file. And so we can start by setting a file path variable. This is just a common way to do it. We're going to say fp is equal to Kumpula June 2016 with metadata. So I just typed in the capital K and hit tab, and then hit down arrow a couple times to choose the file name. IPython and Jupyter notebooks are pretty smart about knowing these auto completions. So we set the file path, and then we're going to read the file first using pandas. And so we'll create a variable called data frame, and that's going to be equal to pd.read CSV, which is the it's read underscore CSV. That's the function that's used to read in files from a comma separated value file. And then we're going to put in our file path here. So it's just fp is the name of the variable. Alternatively, we could just list the file name in here, but this is a very common way to do things, to define this file path variable. In fact, if you wanted to, you could put the complete path to the file so that you can always read the data file from any working directory. Here I've made sure that we're working in the same directory where this file already exists. And since you've probably seen in lesson 5 that there is a header on this data file, we're going to have to add one extra thing in here, and that is this skip rows option, or skip rows parameter, to tell us to skip the first 8 rows. As it turns out, in this data file, there are 8 rows of metadata that basically just tells a little bit about what is contained in the file, but doesn't actually have any useful data in terms of what we would want to analyze. So if we read that in, there should be no issue. And then what you should be able to do at that stage is print out data frame to see what's there. And when you do that, then lost my mouse cursor for a second. Then you should see here that we have 4 columns of data. So there's something here called year moda. This is the year, month, and date or day of some temperature observation, a temperature, and then the maximum temperature for that day and the minimum temperature for that day. So this is the mean temperature average for the day in the temperature column. And over on the left side, you can see the index going from 0 to 29. There's 30 values there because this happens to be data for the month of June, and there's 30 days in June. So we've read the data using pandas. It looks nice. We've got a good amount of information here already that we can work with. And of course, we can play around with modifying this data, adding in different columns and things like that. But next, we can read the data file using NumPy. So same operation, more or less. We don't need to define fp, the file path, because that's already been done. And we're going to use this generic data or generic file reader in NumPy called gen from text or gen from txt. Of course, we give fp there, and as was the case previously, we also do need to use something to tell NumPy to skip over some of the rows. In this case, it's called skip underscore header. Instead of skip rows, just a different option. And we're going to skip the first 9 rows because in this case, we don't actually want to read in the text here that gives the name of what each of these columns is called in this case. So we're going to keep it sort of simple here. Skip all 9 rows so that we'll skip over the column, or the row that would have year, mode, moda, temp, max, and min in there. And with the generic file reader in NumPy, we also do need to specify what is the thing that is separating the values in different columns, the delimiter. And in this case, our delimiter is a comma. So if we run this, then what we should expect to see here is basically the same data that we've just read into Pandas, with the exception that we don't have these names for the different columns. We'll come back to that. But we should see that the first column of our data array is something like a date, and then temperature, and then max temp and min temp, same as we saw before. So I'm just going to read that in. And now, same thing that we did with the data frame, we'll just print out what data contains. So if we print data, now it doesn't quite follow the same format as what we saw in Pandas. That's a nice thing in Pandas, is the formatting of the output looks quite good on the screen. But you can see more or less the same information here. It's shown in scientific notation in this case, so it's a little bit harder to see. But you can see that 2016-0601 would be the 1st of June 2016 times 10 to the 7. So that's 2.1016 blah 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 times 10 to the 7 would give you that same 8-digit number that we had before. And likewise, you can see the minimum and maximum and average temperatures have been read in just by using this gen from text command, and everything appears to be sort of properly separated into separate rows and columns. So that's good. We didn't just get a big blob of data. We've properly separated things. Now, the step that normally happens when dealing with this kind of data is to split it up into separate column arrays, or separate one-dimensional NumPy arrays to interact with it. There's lots of different ways in which you could do this, but something that's somewhat challenging in NumPy is the fact that it doesn't quite have the same flexibility that Pandas has to be able to read in different data types and properly handle them. Basically, if you're just using a standard NumPy array, all of the data must be in the same data type. So often when you want to interact with different data from some file that you've loaded in, you're wanting to split things out into separate variables to interact with it. So, we could, for instance, here with the Pandas example, I think there was something of calculating what the range of temperatures was for the day, the difference between the max and the min, and putting that into a new column. In Pandas, that's pretty easy. We could do the same thing in NumPy. But to do it first in NumPy, we should associate some names to the different values that are in the data file that we've just read in. So I'll show how to do that. It's probably a review for those of you who've done the NumPy exercises, but if it's not, you'll at least see kind of how I tend to work in NumPy. There's probably other methods to doing the same thing, but this is my tendency. So first thing to think about is that we can split out different parts of this data set by using these index values. So we could take, for instance, data and 0, colon, and that will give us the first row of our data file. So this is a two-dimensional structure here. So you can see, for instance, there are values that go with the rows and columns. And in this case, the first index refers to which row we're looking at, and the second index refers to, that's right, first row, and then the second index is the column. And in this case, I've just put a colon here to say I want all of the columns. And so what you see is the first row of the data, all the values that are connected to the 1st of June, 2016. So this is, I'll just add in the note here, first column, or first row of data file. Right, so we see that. If we want to get the first column of the data file, we can do something quite similar. We just say, in this case, data, colon, comma, 0. So in this case, all rows and only the first column, the one at index 0. And if we do that, then we see, looks slightly different format, but basically 2016-0601, 2016-0602, and on up to 2016-0630, which would be 30th of June. Everything looks okay here. This is basically what we're going to take advantage of when we want to separate the different columns into different named variables. So for instance here, if we want to make a new NumPy array in this case with the dates in there, we can say that the date is equal to the first column from our data file. So I'll just copy and paste that. We also know that the temp variable is equal to the second column, so this is going to be colon comma 1, and that max is going to be data colon comma 2, and then min is going to be data colon comma 3. Now I'm actually going to change these variable names. They've lit up in green because there's max and min functions, so I'm going to make this be max temp and min temp, just to have some better variable names. So this will then split our data. It will keep the original data that we've loaded in as the variable data intact, but then we're going to create 4 new NumPy arrays that are just a one-dimensional thing. You could think of it as just a single column from the file with the date, the temperature, the max temp, and the min temp there. So this is just taking advantage of the array slicing in basically any kind of collection in Python. So now if we did print something like temp, we can see here our temperature values. So I'll just add a comment up here, split data into 1D arrays, and make it clear that's NumPy stuff. And then we just print out the values there. If we want to do the equivalent option of printing out what the temperature is in our data frame in Pandas, we would print data frame, and then in square brackets, the name of the variable that corresponds to which column we're referring to. So you don't have to worry about whether temp is the second or first or third column, whatever. You just know that there is a variable here called temp, and you can get those values by printing out data frame with the square brackets and then temp inside. And you'll see the same information more or less in a slightly different format, because here Pandas is giving us also the index along the left side there. And but you can clearly see that these two things are basically equivalent to one another. So just to kind of continue with doing one small operation in both Pandas and NumPy, one thing we could think about is we could create maybe I'll just show temperatures in Pandas. We're going to create a temperature range variable. That'll give us the range of temperatures from the kind of minimum to the maximum in both Pandas and NumPy. And frankly, we'll call this a column for the NumPy case, because what we're going to do is just add another column to our data frame. So we can do this first in NumPy. And in NumPy, all we would do is say that we had temp underscore range. So this is a new variable, and it's going to be equal to temp, I guess it's max temp minus min temp. Okay, so we just take our variable here. So we've got this 1D array called max temp, a 1D array called min temp, and if you take the difference between the two and store that, this is a NumPy array, that's a NumPy array, so the output will also be a NumPy array called temp range. If we do the same thing in Pandas, we could basically say that our data frame, and we'll make a new variable here called temp range, and that's simply equal to data frame max minus data frame min. So it looks pretty similar in a sense, because basically we're just taking the difference between the max and the min columns here, and we're going to create a new variable or new column in our data frame called temp range. If I run those two cells, I get no complaints. That's good. And now if I print out temp range, you can see here the variation in temperature for these different days. So this is temperatures in Fahrenheit in this case, but it's something like 15 to 20 degrees on average per day. Difference between the maximum and minimum temperature. And if we did the same thing, in Pandas, we would do data frame, then the square brackets, and this is going to be temp underscore range, the new variable we created. And sure enough, we see the same values here in temp range. The difference, of course, is that if we go back to just printing out the entire data frame in Pandas, this is where things are going to be a bit different from where they were in what we were dealing with NumPy. So now you can see here, we've basically added an extra column to this data frame. So now we've got 5 columns, same number of rows that we had before. If we printed out our data in NumPy, this is still the same original 4 columns because we haven't modified anything. We split this thing into separate individual 1D arrays, so separate column arrays for the different values that were read in the data file. And now we've created a new data file, or a new sort of, new 1D array called temp range to store the range in temperatures that we've calculated. So things diverge a little bit. There are ways we can do somewhat similar things in NumPy, but adding columns to an existing NumPy array is not necessarily a trivial operation. You can do it. There are ways to do this, and of course you can basically solve any kind of problem like this you want to when they come up in NumPy, but the problem becomes it's just not always straightforward. So, one of the solutions in NumPy is that you can often reshape your arrays. So there's ways you can take something like this, what we see here, as 4 columns and 30 rows, and basically create a single 1D array that's 120 rows long, add values to the bottom of it for the temperature range, and then reshape it back into being 30 rows, 30 rows and 5 columns with your new values added in there. So you can play around with this stuff. There are solutions for it, but it's just not always easy to do. And in part, that's because NumPy is a little bit more general. It's not necessarily built around the idea of working with data files the way that I understand Pandas is. I mean, Pandas really seems to be focused on data analysis, loading in files, manipulating data, cleaning your data, consolidating values and things like this. And NumPy can do that stuff, but it's not necessarily designed for that purpose, which is why some of these things are a bit more challenging. And also the reason why I suggested that it's probably better to follow the Pandas part of the lessons here for the course at this stage, because even though I'm less familiar with it and can provide perhaps a little bit less detailed commentary on how Pandas works, I think it's generally easier to work with. It just happens I've worked with NumPy for years before I even knew about Pandas, so for me, I've maybe found the hard way to do things, and it's easier for me to remember to do things the hard way than to learn to do things some different way. So that's a little bit of the kind of small differences. Of course, we can go through the rest of like lesson 5 and show many different things that are there. I mean, there's things that we can see, like if we print out the data frame dot shape, I think we can do that. So you can see it's 30 by 5. If we print out data.shape, it shows us it's 30 by 4, so 30 rows, 4 columns, like data frame dot calls, is it? I can never remember if it's calls or columns. Let me quickly consult columns. So you can quickly get things like the list of the different variables in the data frame. And there's also some kind of cool things like dataframe.describe, which I think is pretty nice because it will show you the variable, how many values of that variable are in your data set. Really nice if you want to know if you're missing any data in the data file. What the mean value is, standard deviation, min, and then these different kind of quartiles, and then also the maximum values for the different variables. So Pandas has some cool stuff in there that you can do. Just like NumPy, you can take something like data frame, let's go with temp, and I think you can do dot max of that to get the maximum temperature using pandas. Of course, in NumPy, you can do exactly the same thing, just with temp as our variable. Temp.max gives you back the same maximum temperature as would be expected. Pandas is using NumPy under the hood, so that's not really a big surprise that some of these things that work in NumPy are also available in Pandas. So there's more stuff in the lesson about how to do some basic exploration of the data file that you've loaded in, but I think maybe here I'll pause for a moment and see, are there any questions, because we could go into other stuff in more detail, talk about, I don't know, some of the exercise things if needed, but maybe it's good if you have any questions that you have a moment to think of those, and maybe you can let me know. So I'm not seeing much in Slack or in the YouTube chat. So, I'm not exactly sure what would be useful to review at this stage, because I don't know exactly where everybody is at in terms of what they're working on, and the kinds of things that might be handy. I guess we could talk a little bit about some data filtering. We talked about that a little bit last week, because I think there had been a question in Slack maybe a couple weeks ago about keeping your original data intact and pulling out some values using NumPy. And I think there's at least maybe one useful thing that came up in just reviewing lesson 5 that I could maybe say a couple things about here first. So I guess if we say something here about let's make a markdown cell and call this filtering data. So the idea with filtering data is that we often have a data file where we want to extract values that meet some criterion, and that could be, for instance, temperatures that are above a certain value or below a certain value, dates that are the first half of some month or something like that. And so we can play around with that kind of stuff both in Pandas and NumPy here. I'm realizing maybe this is going to be confusing in the sense that I'm switching between the two, but I think in some ways it's also good just to see how things are a little bit different between the two in terms of helping you decide what you might want to use yourself in the future. So let's imagine a scenario. Let's imagine that we're interested in let's say we want to know let's say we want to know the days in June with a temperature range of more than 20 degrees. And we're going to work in Fahrenheit for now just because I don't feel like bothering with making a conversion function and moving the data over to Celsius. That's not hard to do. I just don't feel like I'm mentally up for it right now. So we can do this in Pandas first. And the way that we would do that is we have our variable here called temp range. And if we want to know the dates where the temperature range is greater than some value, well, we can do that pretty easily. I'm just going to make sure I do this the Pandas way. And see if I can find where this happened in the lesson. There we go. Yeah, okay. So what we want in Pandas would be to say like our data frame dot loc. So these are going to be the locations in our data frame where some criterion is met. In this case, what we want is our data frame temp range to be greater than 20 degrees. And if we do that and run that cell, we get this nice looking output. This is one of the kind of cool things about Jupyter Notebooks. You get very nicely formatted output for certain kinds of things like this. I get a nice little table. And not only does it show the temperature range values themselves, but all of the information for the different columns when the range in temperatures was greater than 20 degrees Fahrenheit for that day. So that's kind of handy. And so what you see is that in this case, it's mainly happening in the first half of the month, which is kind of an interesting scenario to consider. If we wanted to do the same thing using NumPy, we can, but this is where it becomes a little bit different from what you would do with Pandas. What you do here in Pandas is basically a single line command, dataframe.location, and the criterion that should be met to give you back the values you want. In NumPy, we're going to have to make a mask first because we've split the data out into separate column vectors. We didn't necessarily have to, but we did. And now to get those equivalent conditions met, we need to create some array of true or false values where we can then look at different variables we've defined to see if they meet this criterion. So first we're going to do this thing where we'll define a variable called mask. In this case, mask is going to be equal to a true or false statement. So what we want to say here is temp underscore range. That's the variable we have defined for the temperature range, greater than 20 degrees. So temperature range greater than 20 degrees will return either a true or a false value for each row in our column of temperature range values. And then that true or false will get stored in a variable called mask. So so we're going to make a range that, or a mask that says the condition temperature range should be more than 20. And next, we can then use the mask to check our output. So here, in this case, if we want to compare against the date column that we have from Pandas, we could say that the date, where we use the mask as our filter, so we can print out date with mask in square brackets. So what that's going to do is basically print out the dates where this condition is met for the variable date. And if we do those two things, what we see is it's 2nd, 3rd, 4th, 11th, 13th, 15th, and 21st of June. 2nd, 3rd, 4th, 11th, 13th, 15th, 21. So same output here, and if we wanted to, then we could basically do the same thing for temp with this mask. And again, similarly, we would see these temperatures 68.5 or 65.8, 68.4, 57.5, 54, 58, 63, and 62.6. Those should be all the same temperatures that are in this row or this column of temperatures in the Pandas data frame here. So same operation, different pathway to get there, but it's doable. And this is commonly the case with NumPy stuff, is that it is doable. But it may be a little bit more challenging, kind of depends on what you're trying to do. I like this Pandas data frame option with the location because it's really easy just to only display the values for all columns that meet some condition in a single one-line command. So the thing that I wanted to come back to briefly had to do with what happens when you want to meet more than one condition. And so, like, let's say, because we're sadistic, that we wanted to not only look at the days in June where the temperature range is more than 20 degrees Fahrenheit, but also only the days that are even. So only the 2nd, 4th, 6th, 8th, 10th day of the month. So I'm going to copy this text from the markdown cell up here down to another one. Oops. And make that a markdown cell. So now imagine that we're interested in the even days in June with a temperature range of more than 20 degrees Fahrenheit. Why would you want to know that? I don't know. But it's just a demonstration for this case that we want to have two conditions. First off, it should be an even day. And secondly, it should be a day in which the temperature range is more than 20 degrees. Let's start with Pandas. I guess first off, we should think about how do we determine whether the day is even. And that's actually not a terribly difficult thing to do, but it's probably not something you've thought through. But there is a command in, an operation in Python for doing division, where you want to do kind of like long division with the remainder. So if you take, for instance, 4 divided by 2, and actually I'll get rid of the pandas thing here for right now. As expected, you get back 2.0. If you do 4% 2, you get back 0. And you might say, well, what does that mean? This percent sign is an operator called modulo or something like that. I can never remember what it's actually called. But what it does is it gives you the remainder when you do division of the number 4 by the number 2. Of course, the number 2 goes into 4 2 times, And so in that case, we get back a remainder of 0 because you can put it in 2 whole times. If you did 5% 2, you get a remainder of 1. So, oops. I'll just copy the same comment here. Okay, so why am I showing you this? Well, because you can use this as a way of determining whether a number is odd or even. If you can divide by 2 and you get a 0 back, you know it's an even number. All of our dates should work such that the day itself is the first 2 numbers in the dates that we're looking at. So when we divide those whole dates by 2, if we get a 0 back, we know we have an even day. If we get something that's not 0, like 1 back, then we have an odd day. So that's how we're going to set up our condition here in Pandas. So let's do it. Now we got to meet 2 conditions, so we also have to play around with that. But what we're going to do here is take what we had before, because we already had something that worked, and that was to find our temperature range greater than 20 degrees. So we found the values that meet this condition using this. Now, to add in a separate or second condition, we're going to put in this ampersand, this and sign. And in addition, we have to put this first thing in parentheses. So our first condition that we should meet has to be in parentheses, then an ampersand, and then our second condition will also be in parentheses. In this case, our second condition is that we want the year mode value when divided by 2 should have a remainder that's equal to 0. So this will take the year, month, date value and do this division by 2 where it calculates what the remainder is. And that remainder value should be equal to 0 in order for us to pass that condition. So we have our original condition in parentheses, ampersand, and our second condition is here. And that is that when we do this division by 2, we should get a value back that's equal to 0 in order to pass that condition. That looks good. Now, before we run this, let's take a look. What should we expect to see here? Well, we only have 2 days where we should expect output at this stage, because all of the other dates here, so 3rd of June, 11th, 13th, 15th, and 21st are all odd. Those should all drop, and this should give us back only our 2 dates. If everything is going well in the world, let's see, it works. So now we have only the even days in June where the temperature range for that day exceeds 20 degrees Fahrenheit. So that is something special, and wasn't necessarily that hard to do, but it just takes a little bit of thought here. And the real challenge in this case is understanding, first off, I think the condition, at least this one, is not so hard to understand. You're just getting the values when the temperature range is greater than 20 degrees. Here, we're getting a condition where when you do this division, its output is exactly equal to 0. That tells us we have an even day. And the ampersand here is basically, it is a logical and operator. So for all of the cases where this condition is true and that condition is true, we would get output. If we wanted to, well, let's do the same thing in NumPy, then I'll show you one small variation, and then I'll probably wrap up for the day because we're kind of out of time. So that's how we do things in Pandas. Let's see what would we have to do in NumPy. Well, it's actually not so different. In fact, I'm going to go back up here and copy what we had before and paste it down here, because We already did something like this. So before, our mask was that we had temp range greater than 20 degrees. Here, we're going to do basically exactly the same thing we did in Pandas. We'll put our first condition in parentheses, add an ampersand sign, and then give a second condition. In this case, our second condition should be that the date %2 equals 0. So I guess I didn't say it sort of clearly, but when you have a double equal sign, that's doing the sort of test to see if you meet this condition of being equal to 0. If you had a single equal sign, it would basically be trying to assign this date value equal to 0, and it would complain because you're trying to do two operations and you would get some kind of syntax error. Here, the double equal sign is just to do a comparison to say, is the value exactly equal to 0? So all we've done is just kind of minor modification to defining this variable called mask, so that now we have these two conditions. And now when I run this same thing we did before, the dates that I get back are the 2nd and 4th of June, just like we had above. And of course, I could do the same thing using the mask on temp, max, min, whatever, and get back those values as well. So that is our case for wanting to have even days in June with the temperature range of more than 20 degrees Fahrenheit. Our last thing that we'll explore here, just for fun, is that imagine we're interested in the even days in June, or those with a temperature range of more than 20 degrees Fahrenheit. This is different. So now what we're going to do is see any day in June that is even or has a temperature range of more than 20 degrees Fahrenheit. We're going to get more output this way. We're going to follow the same kind of general formula that we followed before. So I'm going to copy this cell here from Pandas for how we did this before, and I'm going to make a single change, and that will be to replace this and, which was the logical and operator, with a vertical bar. So I guess for those using a Finnish keyboard, you probably don't use the vertical bar that often. For me on a Mac, it's Option 7. I guess it's probably Alt 7 or something like that on Windows or in Linux. But so or will basically give us output for this condition being true or that condition being true. So it's a little bit of a different operator. Depending on what you're doing, you have to often decide, do I want and as my condition when I have to meet two conditions, or do I want or to say I want values that meet either of these two conditions. So let's say you had a whole list of animals, and for each animal you had like its type of animal, like dog, cat, fish, whatever. If you wanted to find out which animals are dogs or cats, then you would be using this or operator. And that's that. So a single change from what we had before gives us a whole bunch of additional output, because now we're going to get every day that is even in the month of June. So we should see here 2nd, 4th, 6th, 8th, 10, 12, they're all there. And we're also going to get the days where the temperature range is greater than 20 degrees. So if you see any of these odd days in here, like the 3rd of June, you should be able to look over and see that the temperature range is in fact greater than 20. And the same thing would work for any of those days there. Obviously, you can see plenty of days here where the temperature range is not greater than 20 degrees. And those are dates when you're not passing the test in the first one here, so you don't pass this condition, but you have an even day, so you get the output that way. If we did the same thing in NumPy, again, we'll do a little quick copy paste from what we had before. So here's our temperature condition before. Temperature range was greater than 20 and the date divided by 2 had a remainder of 0. We'll just again switch this Option 7, get a vertical bar there for the or operator, And again, if we run this cell at this stage, we get the same list of dates back that we had previously. So that was about all I had in mind for today. I guess I didn't really get into too much of stuff that was handled in lesson 6. I didn't talk much about what was done in the exercises, but I thought maybe some of these things are useful for your interests in using either NumPy or Pandas to interact with file data. Are there any questions? I can't really tell how far ahead I am, but yeah, I'll pause here for a second and see if there's anything. If there's not, I think I'm kind of out of ideas of what else to talk about at the moment. But I can save this Jupyter notebook with the stuff we've been going over and put it into the Git repository where the notebook was from last week, so I can add this there in case you're kind of wanting to go back and look through some of this stuff and see how it works. Yeah. Anything from those in Slack? Not seeing much. So, all right, I think I'll call, only a comment. Okay, so most students are done with exercise 6 already, so things should be pretty clear so far. Okay, that's good. If most people are done already with exercise 6, then maybe next time I'll leave the possibility of asking questions about lesson 6 available, but maybe we could just jump right to plotting and dealing with the stuff with Matplotlib, because there's plenty of things that we could cover and play around with there that that might be interesting to either supplement or help with exercise number 7. Yeah. If there's not anything else, I think then maybe I'll stop here and we can come back to this next week with maybe a little bit of stuff on Matplotlib and just plotting in Python in general, so that that might be more useful if people are still kind of working on this exercise number 7. Otherwise, the plotting stuff I think is also just useful to give yourself a better idea of what you can do with Python. And it's been the experience so far, at least with the students here in Helsinki, that a number of them have switched over to doing a lot of the plots and things like that for the exercises in various courses using Python now. So that was a good kind of positive thing to see. So, okay. Well, I think that's it for this week. So we'll continue next week, and we'll try to maybe put the link to YouTube up a bit earlier so that there's more time for people to ask questions in advance in case there's anything from lesson 6 or exercise 6 that comes up. So, all right, that's it for me, and I'll see you guys next week.